Good afternoon, my YouTube viewers. In this video, we're going to be covering a practice question with the t-distribution. And the t-distribution is similar to the normal distribution with the exception that the t-distribution has heavier tails than the normal distribution. So this practice question that we're going to be going over is going to be on drug trials. So two groups of patients are being compared for a new drug's effectiveness. Group A with N equals 15 has an average improvement score of 8 with a standard deviation of 2. Group B, N equals 10, has an average improvement score of 6 with a standard deviation of 1.5. Is there a significant difference between the two groups at the 0.05 significance level? And we're going to perform an independent two-sample t-test to answer this question. And so basically what we're going to do is we're going to write a program in Python to answer the question. And in order to write the program in Python, we're going to have to import scipy, which is Python's scientific library. So from scipy, we're going to import stats. And stats is a statistical module within scipy. So we're going to set up these statistics for group A, which mean A equals 8, and standard deviation A equals 2, and NA equals 15. So that's the number of participants. The sample statistics for group B is mean B equals 6, standard deviation B equals 1.5, and the number B equals 10. So we're going to perform an independent two-sample t-test with unequal variances. So this is also called the Welch's t-test. So t-stat, p-value equals stats dot t-test independent from stats. Brackets, mean 1 equals mean A, comma, standard deviation 1 equals standard deviation A, comma, knobs 1, that's number of observations, 1 equals NA, and comma, mean 2 equals mean B, comma, standard deviation 2 equals standard deviation B, and knobs 2, that's number of observations, 2 equals NB, and equal variance is false. So now what we're going to do is we're going to output the results. We're going to print the t-statistic, and we're going to print the p-value. So we're going to determine if we're going to reject or accept the null hypothesis. So alpha is your significance level, and it's 0.05. If p-value is less than alpha, you're going to reject the null hypothesis because there is a significant difference between the two groups. And else, if p-value is greater than alpha or greater than 0.05, you're going to fail to reject the null hypothesis because there is no significant difference between the two groups. But you know that, so let's see what we've got here. So your t-statistic is 2.85. Your p-value is 0.0091. So it is less than 0.05. And since the p-value is less than 0.05, you're going to have to reject the null hypothesis because there is a significant difference between the two groups. And the null hypothesis is there's no significance difference between the two groups. And the alternate hypothesis is there is a significant difference between the two groups. So when you reject the null hypothesis, you're actually going with the alternate hypothesis. So that's it for this particular practice question. The next question will be on a diet, and I hope that you decide to watch it.